You may have heard mention about SPACs in the news a lot lately. What's a SPAC, you say? Well, tune in on Monday when we will bring back one of our favorite episodes from this past year about a cybersecurity SPAC. And be sure to listen to the end to hear a new interview with one of the original guests. Thanks to our title sponsor, ExtraHop, for making Research Saturday possible. Hello, everyone, and welcome to the CyberWire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down threats and vulnerabilities, solving some of the hard problems of protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
And we already have this common conductive medium, that is the body itself. So why can we not use the body as a wire so that we get the orders of magnitude more efficiency and physical security for devices communicating around the body?
That's Dr. Shreyas Sen. He's an associate professor at Purdue University. The research we're discussing today is titled Enabling New Interaction Modalities by Communicating Strictly Through Touch Using Electro-Quasistatic Human Body Communication. And now, a word from our sponsor, ExtraHop, securing modern business with cloud-native network detection and response. The massive shift to remote work has turned the reality of work on its head. With cloud and multi-cloud adoption, comprehensive visibility is more important than ever. But in order to protect your business, you need more than unified visibility. You need intelligence response workflows so teams can collaborate easily and act quickly. Thanks also to our sponsor, Verizon, who for nearly 2 decades has helped secure data, networks, and infrastructure of many of the world's best-known organizations. Their annual data breach investigations report is considered the gold standard of cybercrime research, and Verizon's leadership in network, wireless, and IoT connectivity makes it uniquely capable of protecting the ever-expanding attack surface. Let Verizon help you optimize your defenses and achieve the maximum return on your security investments. Learn more at verizonenterprise.com/products/security.
So think about, you have two devices on the body. Let's say maybe your smartwatch and another device. Let's take your earpod. Today, what happens is when we want to communicate digital information from one device to another, we take the digital information, put it on an electromagnetic carrier, and radiate it. That radiated signal goes all around us, for example, in Bluetooth up to 30 feet distance, and can be picked up by anybody in the physical proximity. And only a very small fraction of this signal gets picked up in the other device. So we are kind of wasting energy, sending signals to all the places where it should have only stayed around my body. And also we are creating a security risk because anybody within a Starbucks size coffee shop can now try to snoop into my signal because they have the physical signals themselves. So what we started thinking is because body is conductive, why not couple this signal in a different frequency range called the Electro-Quasistatic frequency, or that's where the name EQS, HBC, EQS standing for Electro-Quasistatic and HBC standing for Human Body Communication, comes from. We published this last year in Nature Scientific Reports, as well as this month there is a feature article on IEEE Spectrum where these concepts are explained. But long story short, what it does is it couples tiny amounts of electrical signals from this watch, let's say, to your body. And that signal is accessible anywhere around your body, but not off of your body.
So are we essentially using our body as an antenna?
Because we want to
short-range antenna, extremely short-range antenna?
Somewhat, but not antenna, wire. Think of the like a copper wire that through which we communicate signals. We are turning our body into a wire.
And so what are some of the practical applications that you all have thought of here to use this?
Yeah, so there are many applications, and I'll come to the touch application in a minute. So out of the many applications, it can be, future body area network, your watch talking to your earpod, augmented reality, virtual reality, medical devices around the body, connected medical devices. Anything that is on or in or around your body that uses Bluetooth today could be using this body as a wire technology, making things much more secure because the signals are not getting radiated and energy efficient. Now, one of the key applications that you are pointing out here is that was the science of the technology, how to turn the body into a wire. Now, what we did in the recent news release and the paper that got published in the Transaction of Computer-Human Interaction, TOCAI, and the CHI conference, it is going to be presented next year, which is the leading conference in human-computer interaction. We are going to show that once you couple the signal onto your body, we are confining it within less than a centimeter of your fingertip, which means imagine you have a signal, digital signal on your body, and your fingertip is empowered with the digital signal. So if you can touch something, that will get the digital signal, but nothing else will get it. So I can open a computer by touching the touchpad. I can open a door just by touching it. And this can create a second factor authentication. From, today we are increasingly using multi-factor authentications and we have to open our phone to get the second factor. It will be possible to just touch and send this digital second factor through the touch in a seamless gesture. You don't have to get your phone out of your pocket.
And to be clear, I mean, this is different from, say, something like Touch ID, which is scanning your fingerprint, but it could work alongside something like that.
Exactly, and that can become the second and third factor. When you touch, you have the fingerprint. Of course, that's the great biometric thing, but also that your fingerprint is one time throughout your life. So if that gets compromised, then it's done. We cannot change it. So pairing it with some changing passwords is something people anyway want to do. So what we are talking about in the same seamless gesture where you are touching some electrode to give the biometric fingerprint, simultaneously overlaying a digital password communication through that. It can be with the biometric or even without, but these are two orthogonal technologies that can be seamlessly combined in one gesture.
And so far, what kind of data rates have you been able to achieve? How much information can you send?
So we have two different sets of prototypes. One we are developing our own integrated circuits also. So I'll tell you, with off-the-shelf modified devices, we are achieving 10 kilobits per second kind of data rates, which are good enough for this kind of security applications as well as biomedical signal communication. And then we are also pioneering our own application-specific integrated circuit through which we have shown more than 10 megabits per second kind of communication as well.
Now, is there any bi-directionality here? In other words, can you send information back through your finger to, say, a smartwatch, something like that?
Yeah, definitely. Just the easiest way of thinking of this is like your body is a wire now. So like you can send things back through a wire, same you can now use the body to send it back from the computer to your smartwatch.
And speaking of efficiency, which is one of the benefits that you're discussing here, in the example of, say, sending information, through your fingertip to log into something, would that information just be constantly broadcast in a repeating kind of signal, or would there be some way to sense when you're actually touching something?
Yeah, it should not be broadcasted all the time. There are a few different ways one can implement the full system, and we have considered some of those. So I'll give you two examples. One is, yes, when you are touching something, you have some sensor that detects a touch and then activates the system. That's one possibility. A second possibility is the computer then sends a request for this ID, like what you would do in a RFID kind of system, right? And then the smartwatch sends that ID back. So there are many different ways the system can be implemented, but so that it only sends when needed and not broadcast all the time.
And what about the possibility of sending information person to person? Could I transfer my contact information through a handshake?
Yes, that was the motivation when I started this. If you read my first paper back in February 2016, I have a nice picture showing, a man and a lady is handshaking and they're sending a business card, so that we don't have to give the business cards anymore. Yes, we can do that, and we now, after 4 years of effort, have a prototype that is able to do that.
So, what are some of the things that you have in your imagination here, in applications for this looking forward?
So, one of the things we have been exploring is, I will explain this from two aspects. One, that communication strictly through touch, this one, and then I'll explain the broader body as a wire concept. So, the communication through touch, we think, opening computers, this multi-factor authentication is increasing significantly, and people are carrying these key fobs with them. There's a company called Ubico, and people are using this YubiKey and similar other devices.
Right.
So you don't have to carry that extra device. Your smartwatch or any other device that you wear becomes that second device with this technology. If you were trying to do it, for example, from your smartphone, then the smartphone had to send it using a Bluetooth, which then increases vulnerability, because then the signals, again, in somebody in physical proximity can sense it. So if you think of the key fob from where the key comes, it basically gets plugged into a USB-C. So the communication happens through that USB-C, and hence it's secure. What we are doing is we are now able to take that. You don't have to plug it in the USB-C anymore. It can be anywhere on your body, and the body is your secure channel, sending that unique key to do logins. So we believe that using the body as a wire has a significant possibility of growth in the multi-factor authentication space, as well as today, if you imagine when we touch displays, we are just giving out the information of which location we are touching. That's all the display understands. But now with this technology, if in future it is integrated with the displays, you are not only sending where I am touching, I am also sending who is touching or what heart rate they have right now, and many other overlaid information. So that's where I said in the Purdue news release that you can log into your profile on somebody else's phone just by touching the app. Think about that for a minute, right? So
yeah,
today we have to log in prior and keep that information, and then when I touch, all it says, open this app, and it uses the prior login information. But in future, what can happen is when I'm touching, it simultaneously sends the login information. So anybody can open that. For example, think of Uber terminals, touch-based Uber terminals in an airport. You don't have to log things in. You can just touch, and you will automatically log in.
So essentially, you're carrying your ID on, for example, your smartwatch, and you're able to verify who you are by just touching things that would be sensitive to this sort of communication.
That's correct.
Now, to be clear here, we're using the human body, the bag of meat that is you or me,
right,
as the conduit for this signal, and there's nothing specific about you versus me. This system isn't measuring anything particular about you or me. It's not using your specific biometrics or my specific biometrics to roll into any of the security. It's really using the specifics of our flesh to keep it from, as you say, to use as a wire rather than being broadcast at any distance.
Yes, that is correct. That's what the body as a wire technology or Electro-Quasistatic HBC does. But of course, the prototypes we are developing also, in certain applications, tries to couple it with the biometric. For example, from the smartwatch, you can imagine collecting your heart rate, which can act as a unique biometric, then digitizing it, sending it through your body, and then when you touch with a fingertip, you can simultaneously get your fingerprint and also the digital signal which contains your heart rate. So you can do many factor authentication in one single touch gesture.
I'm thinking of applications also. There's been concern lately about, for example, if I want to get into a bar and prove that I'm of age, to be able to go in there and have a drink with my friends. If I hand over my ID, that has a lot of information on it beyond just the fact that I'm, in this case, over 21. It has my home address. It has, a picture of me, and I may not want to share all of that information. It seems to me like a technology such as yours, you'd be able to limit that, have something at the door that I can touch, and it'll just ask that specific question. Can you verify that you are of age? The systems exchange information and say, yep, this person's good, let them in.
Yes, absolutely. That's a great example. The touch is only one aspect of it, but body area networks, we need medical devices, connected medical devices monitored in a secure and extremely energy efficient way. In the low speed application of body as aware. For high speed application, there is a huge boom in augmented reality, virtual reality, which can be using this body as aware technology. So in summary, basically anything for which you think Bluetooth is used today around the body, this can replace it and make it better. It's like 100x lower energy than Bluetooth and physically secure. So we see huge application space, and multiple different large companies as well as startups have shown interest, including the touch-based ID kind of a technology. And we are working on them to develop some of this technology and try to bring it to market.
Well, it's very exciting. I wish you all well. It's interesting to see progress in this space, and it seems as though you all are really onto something. This is exciting research.
Thank you. It's great discussing with you.
Our thanks to Dr. Shreyas Sen from Purdue University for joining us. The research is titled Enabling New Interaction Modalities by Communicating Strictly During Touch Using Electro-Quasistatic Human Body Communication. We'll have a link in the show notes. Thanks to ExtraHop for sponsoring our show. You can learn more at extrahop.com/cyber or connect with them on Twitter or Facebook. Our thanks to Verizon for sponsoring our show. You can learn more at verizonenterprise.com/products/security. The CyberWire Research Saturday is proudly produced in Maryland out of the startup studios of Data Tribe, where they're co-building the next generation of cybersecurity teams and technologies. Our amazing CyberWire team is Elliot Peltzman, Puru Prakash, Stefan Vaziri, Kelsey Bond, Tim Nodar, Joe Kerrigan, Carol Terrio, Ben Yellen, Nick Valecki, Gina Johnson, Bennett Moe, Chris Russell, John Petrick, Jennifer Iben, Rick Howard, Peter Kilpie, and I'm Dave Bittner. Thanks for listening.